Chapter 3, Section 3 is about proving that lines are parallel. So by the end of this lesson, you should be able to use the angles formed by a transversal to prove that two lines are parallel. So it's kind of like what we did yesterday, except we're going backwards. So remember we had conditional statements. And a conditional statement said, if P, then Q. A converse, remember, just switches that around and says, if Q, then P. So it's kind of like the backward version of something. So yesterday we talked about the corresponding angles postulate, and today we're going to go backwards. So if two coplanar lines are cut by a random transversal so that a pair of corresponding angles are congruent, like these two, then the two lines have to be parallel. So instead of saying, okay, if two lines are parallel, we have a transversal, then the angles are congruent, we're going backwards. So let's use that converse of the corresponding angles postulate to show that L is parallel to M. So we look at our two lines here. The first piece of information they tell us is that angle 4 is congruent to angle 8. So this angle here and this angle here. Now because these are corresponding angles, we can say that L is parallel to M because angle 4 and angle 8 are corresponding angles. And by the converse corresponding angles postulate, we know that L has to be parallel to M. So now the next one, it's a little more work. I know that angle 3 is 4x minus 80. And I know angle 7 is 3x minus 50. And they told us what x equals. It equals 30. So let's plug it in and see what happens. 4 times 30 minus 80. 4 times 30 is 20. Minus 80 will give me 40. So that means that this angle is 40 degrees. Do the same thing with angle 7. Plug in what x equals. They told us it was 30. This is 90 minus 50, which is 40. So this angle is also 40. And then just like before, because we know those two angles are the same, we can say that L is parallel to M by the converse of the corresponding angle postulate. So another postulate to remember, through a point P, not on line L, there is exactly one line parallel to L. So we have a point P out in space. It can be anywhere in space. And then we have a line L. And it says that P cannot be on L, so P has just got to be somewhere in space. There is exactly one line out there that we can make that's parallel to L. So think about what that means. Some line through P has to be parallel to L. And there's only one way that we can make that happen. So these are parallel here, but there's only one line that can happen to. And I know that seems kind of silly to say, but remember in geometry we have to prove everything. So more converse theorems that we need to know. So we have the converse of the alternate interior angles theorem, the alternate exterior angles theorem, and the same side interior angles theorem. And all of these are the exact same, saying that if you have two angles that are congruent, you can then say that two lines are parallel. So we had alternate interior, we have alternate exterior. If they're congruent, lines are parallel. And then also, remember the same side interior ones, those add up to 180. So if that's true, then we can say that the two lines are parallel. So let's prove one of these, the converse of the alternate exterior angles theorem. So I give you that angle 1 is congruent to angle 2. So let's make a 2-column proof with our statements and our reasons. So the first thing they tell us is that angle 1 is congruent to angle 2. It's given to us. So then take a look at what else we know. We know that angle 1 has to be congruent to angle 3 because of the vertical angles theorem. And then we can use the transitive property. If I know 1 is congruent to 2 and 1 is congruent to 3, I can say that angle 2 has to be congruent to angle 3 by the transitive property of congruence. And then once we know that these two angles are congruent, we can say that L has to be parallel to M because of the converse of corresponding angle postulate. So use the diagram and the given information and the theorems you have learned to show that R is parallel to S. So we have angle 4 is congruent to angle 8. So now sometimes it's kind of hard to see when it's like this, but if you turn your paper sideways, these are alternate exterior angles. And if they're congruent, we can go back and look at these theorems. It says that if two coplanar lines are cut by a transversal so that the pair of alternate exterior angles are congruent, then the two lines have to be parallel. So we're just going to use the converse of alternate exterior angles to say that R is parallel to S. Now the next one's a little harder because again we have a little bit of algebra to do. They're talking about angle 2 and angle 3. So let's plug in what we know x is. The measure of angle 2 is 10 times 5 plus 8. That is 50 plus 8, or 58. So we can put that up here. And then the measure of angle 3, plug in what we know. 25 times 5 is 125. Take away 3 is 122. So now they're not equal. So we can't say that we're going to use any of our angle theorems that have equal measures. But remember, there's one that has supplementary measures. So if two coplanar lines are cut by a transversal so that a pair of same side interior angles are supplementary, then we have two parallel lines. So these are same side interior angles. 58 and 122, we end up with 180 degrees. So because of that, because angle 2 and angle 3 are supplementary, we can use the converse of the same side interior angle theorem. To say that R is parallel to S. So before we do this, this is messed up. We need that L is parallel to M is the given part, and we need to prove that P is parallel to R. So set up our two-column proof. Statement, reasons. Let's draw on what we know. L is parallel to M, so that's what these are for. And then we know angle 1 is congruent to angle 3 here. So let's write down our two givens. I know L is parallel to M. And then I know that angle 1 is congruent to angle 3. So if L is parallel to M, this other angle here, 2, that's labeled, that's going to come in handy. Because if we think about P as our transversal, I know that angle 1 and angle 2 have to be congruent because of the corresponding angles postulate. And once I know that 1 is congruent to 3 and 1 is also congruent to 2, I can jump through all that and say that angle 2 has to be congruent to angle 3 because of the transitive property. So now that I know that angle 2 and angle 3 are congruent, I can say that P has to be parallel to R, and M is acting as my transversal. And we can do this because angle 2 and angle 3 are equal, which is the alternate exterior angles theorem. So we're at the end of the lesson. You should be able to use the angles formed by a transversal to prove that two lines are parallel. Make sure you write down any questions you have and we can go over them in class tomorrow. Have a good night.